Greetings everyone. Today we're going to explore writing quadratic functions for real-world scenarios. Let's take a look at one example. With all of these examples, my suggestion is to doodle a little sketch. Make sure you can make sense of the numbers and the example provided. In this scenario, Matt hit the golf ball off of the ground and it followed a parabolic path, reaching a maximum height of 4 feet. So let's take into account our typical parabola graph that we would have. In this case, he hit it off of the ground, so we do have an initial point at 0, 0. It followed a parabolic path. How this parabola is drawn doesn't really matter. What matters is the key features. It reached a maximum height of 4 feet. If you think about height, that would be my y value. So when I label that point, I'm going to put a 4 in for the y. If the ball hit the ground again, that would be this point here, 10 seconds later. So if I take a look, if the y-axis was my height, then I know my height is back to 0 because it hit the ground again. I have to determine what my x-axis is going to be. And if I look at my label, I have seconds. So the length of time in seconds is going to be my x-axis. So 10 seconds later, it managed to hit the ground. If I take a look, I'm still missing this x value. Remember that your vertex uses the axis of symmetry. If my x values are 0 and 10, then my axis of symmetry needs to occur at 5. So let's label the information we have. We currently have the vertex, and in this particular case, we can call these random points or we can use them as intercepts. If we think back to our previous lesson, we have been using vertex form or intercept form to create our functions. In this case, I have both pieces of information, so I can use either function. I'm going to show both, as sometimes you'll have that option, but other times you'll have to use one or the other. Let's start off with vertex form. From your notes, if you look back, you already know that you have an h and k to represent your vertex, and x and y to represent your coordinate point or random point. Let's start with our vertex. When I look at my vertex, I want to replace h and k with my vertex values. So I'm going to have a -5 and a +4. We don't know our a value. Now I have to decide what I'm going to plug in for my x and my y value. I can choose either point that I haven't used yet. So I'm just going to use 10, 0, but you could use 0, 0 as well. If I plug in 10 for x and 0 for y, I now have enough values that I can reduce and find my a value. In this case, I have 5 squared. That gives me a 25a. Subtract the 4. And I end up with an a value of -4/25. Keep in mind here, this isn't our typical a value, and we won't have our typical a values because these are real-world scenarios. So the values we end up with are going to look very extreme compared to what you're used to. So when you work on today's homework problems, just know you're going to have some very weird values, and decimal values are okay. Sometimes the fraction is just too much to follow through with in the work, so I will accept decimal values. Make sure that you finish the question by actually answering the question by writing out your function, similar to our last lesson and our last worksheet. Let's take a look at intercept form. In intercept form, again, we need to find our a value, but we have x minus p and x minus q. If I look at my intercepts, my P and my Q value are where I cross the x-axis, which would be at 10 and at 0. So for P, I'm going to plug in 0. For Q, I'm going to plug in 10. Order doesn't matter. You could have those numbers reversed. I don't know my A value. Now, if I've already used those two intercepts here, I need to use a different point for my X and my Y values. The only other point I have is 5, 4. So instead of X, I'm going to put a 5, and instead of Y, I'm going to put a 4. Let's simplify. We're going to multiply, and then we're going to divide. You'll notice I arrived at the same solution, which makes me feel more confident in my answer. But now when I write that final function, this is an intercept form. So I'm going to have two parentheses, and I'm going to keep that x minus 0 and that x minus 10. On your homework problems, you're going to stick to one form or the other. Some of them you'll have the option, others you won't. So you need to identify what pieces of information do you have before you proceed. A couple of things to consider as you work your way through these problems. The example we worked on had an initial height of 0, so we started from that usual point of the origin. But don't always expect that to happen. Occasionally, if I'm going to be dropping or throwing something from a building, then I'm going to have an initial height that is higher than 0, and then I'll have that parabola that comes down and hits the ground. Now, no, algebraically, we can still account for both intercepts, but our one intercept is going to have a negative value on the x-axis, so we're not going to necessarily use that. So watch out for problems where you have an initial height that you're working with. In this case, you're most likely going to be given the vertex and maybe just the one random point, which happens to be an x-intercept, and you can use it as that random point. Look out for keywords as you work your way through these problems. For maximum height, that's going to imply your vertex. Think about if they say seconds or some other term of measurement for your x-axis. What are the units that we're using for our x-axis? Also, remember, you're going to have very weird or random A values. Feel free to use decimals. Just make sure that you try to stay as accurate as possible. And what I mean by that is in your work, if you can stick with a fraction, do so. If you do use decimals, make sure you use many decimals in your work before you round at the end if you want an as accurate answer as you can get. For today's homework, we have 10 stations. Each station is its own question, so you will work this out on your own paper. Remember, the end goal is a function, an equation. So I need to see that correct equation in the end. If you have any questions, make sure to check out Google Classroom. Notice that I posted the Sabre Center schedule with certain names highlighted and other teachers that you can find to help you. If you need any extra help from me, just visit with me before or after class and we'll figure it out. See you next time. For those that are actually going to watch this video through its entirety or have checked it out to get some extra help, here's a freebie. Let's walk through question number 3 together. Although a stadium field of synthetic turf appears to be flat, its surface is actually shaped like a parabola. This is so the rainwater runs off the sides. If we graph a cross-section of the turf, where x is the distance from the left end of the field and y is the height of the field, the endpoints would be at 0, 0 and 160, 0. So take a moment to notice, what do those numbers represent? In this case, we have two x-intercepts. Let's keep reading. We know that 10 feet from the left end of the field, the height of the field is 0.3534. Let's label that on our image. We know that 10 feet from the left, we reach a height of 0.3534. Now take a look. Does that look like it's my vertex? They didn't mention anything about a vertex or a maximum or halfway. And if I look, halfway doesn't make sense because halfway would be 80 if the length is 160. So in this case, what that means is this is just a random point. This is a point of 10, 0.3534. So we're going to use that as our random point. It says write the equation in vertex form that would model the surface. So let's take a look. I know my x-intercepts, so I want to start with my x-intercepts, and I'm going to use intercept form. Intercept form again is a with an x minus p, x minus q. I know that my x value of my random point is 10, so I'm going to use that 10 twice. I have an intercept of 0 and an intercept of 160. I don't know my a value. I have a y value of 0.3534. Let's take care of our parentheses. I have a 10 and I have a negative 150. And I still have this crazy decimal. I've got a negative 1,500a. Now as I look at this point, if I go to divide by negative 1,500, let's acknowledge a few things. First of all, I'm going to have a crazy decimal. I'll let you plug that in and find that value. You'll also notice it'll be negative. Well, think about this. This parabola is upside down, so a negative leading coefficient makes sense. So in the end, I'm going to have f of x equals your crazy decimal that you found. Let's go 3 or 4 decimal values. Actually, let's go 4 since this one was 4 as well. And I'm going to stick with my x minus 0 and my x minus 160. Let's go back to the original question though. The original question says, write an equation in vertex form. I'm currently in intercept form. What that means is I need to take the information I have and I need to find the vertex so I can write vertex form. To do that, I know my vertex should occur at the x value of 80, but I don't know the y value. So use your equation. If I take my equation, f of x equals that decimal value, and I have 80 minus 0 and 80 minus 160. Then I can reduce that. Multiply that all out, and you're going to have a very crazy decimal for your answer. And that's okay, because look at what this decimal was. So we're also going to have those decimals occur all along the parabola. So for that value, you just found your y value. So now I can actually use vertex form. Vertex form means I need my function notation, my a value, carry that same a value over. Then we're going to have our x minus our h. In this case, it's 80 squared. And then I have my y value, and I need to take that y value that I found and plug it in here for my vertex. So all you're doing is you're solving, using that x value, solving for y, and then replacing it and using it in vertex form. If you have some questions on this one, we can take a second look in class, but take advantage of this video and jot down everything we've gone over so far. We'll see you in class.